So the next step for our addition and subtraction formulas that we're going to need for the trig functions, it's all in section 7.2. And there's some more nice identities, like I said, for addition and subtraction. These are all listed in your text, but the two that I would really stick with, if I want to take two numbers, s and t, and I want to take the sine of their sum, sine of s, cosine of t, plus cosine of s, sine of t. Now, your book has a separate formula listed where this is subtraction. Turn this into subtraction. Nothing new to memorize there. Cosine of s plus t, we've got cosine s, cosine of t minus sine s, sine t. And again, if you want to turn this to a minus, flip the sign over here. In your book, list formulas for the tangent of s plus t. Now you can go ahead and memorize it, the one that your book gives. Tangent of s plus tangent of t over 1 minus tangent of s, tangent of t, or tangent is sine divided by cosine. If you know these two, you can figure this one out. And that's usually the way we want to do these things. I want to memorize as little as possible, just enough to make sure that I understand the constructions and that I can derive the rest of the results on my own. So if I wanted to use this to come up with something like, say, cosine of pi over 12. Now I could plug that into a calculator, I could get a decent decimal approximation, but I'm much more interested in finding out if I can do it precisely. And for precision, I notice that pi over 12 can be written as pi over 4 minus pi over 6. Now, cosine of pi over 4, I already know, square root of 2 over 2. Cosine of pi over 6, I also know, square root of 3 over 2. So if I go back to my cosine identity, this is the cosine of pi over 4 minus pi over 6. So that's going to be cosine pi over 4 times cosine pi over 6 plus sine pi over 4 sine pi over 6. Now we know that at pi over 4, sine is equal to cosine, so we've got that. The only other piece we need, sine of pi over 6, which we know from previous chapters is equal to a half. So this whole thing ends up being root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1 half, square root of 2, square root of 3, plus square root of 2 all over 4. Or you could rewrite this as square root of 6 plus the square root of 2 over 4. And then you've got a nice precise answer. No decimal approximations needed, and it comes from this formula for doing cosine of a sum and difference of angles. Now another one of these that's nice and follows from the same application would be, there were these cofunction identities that were listed in section 7.1. So the identity that your textbook gives is the cosine of pi over 2 minus u equals sine of u. Now that should make sense to us in the context of the graphs that we were doing all the way back in chapter 5. When we graphed sine and cosine functions, we saw that you were able to obtain the cosine function by taking the graph of the sine function and shifting it by pi over 2 to the right. So this kind of looks like it should work. Let's figure it out. if we use our cosine identity from this, this should be cosine of pi over 2 times the cosine of u plus the sine of pi over 2 times the sine of u. But cosine pi over 2 is 0. So this whole thing is 0. Plus sine of pi over 2 is 1. So all that's left is plus sine u, sine u. Another one of these ones that just falls out really delightfully from these addition formulas for sines and cosines. Now I've got one for you that's a little bit more complicated. Depending on how much pre-calc you've had, you might have seen difference quotients before, but I'll show you one that shows up in calc. If I let my function be the sine of x, of x plus h minus f of x over h, is a form of a difference quotient that shows up a lot in calculus. Now, if this is the function, I've got this to be equal sine of x plus h minus sine x all over h. And I claim this is equal sine x of cosine of h minus 1 over h plus cosine x sine of h over h. And this is something that, again, like I said, will show up in some proofs in a calculus textbook, but we can derive the identity here just from a little bit of trigonometry. I'm going to rely on the fact that right here I've got the sine of two numbers added together, and then I have my addition formula for sine to work on that. So this should be sine of x cosine of h plus cosine x sine h minus sine x all over h. And to simplify that, I know from up here that I'm looking for a way to get a sine as a factor. And I see a sine as a factor of this term and of this term. So if I bring those together, I can factor that out. Sine x times cosine of h minus 1 all over h plus cosine x sine h. And if I take this part here and this part here and I simplify them, split it over this addition, this guy ends up there, and this guy ends up there. As I split this up into two parts, the h comes along with both parts, and I get my identity again. And like the last couple, it comes from there. So, we're going to continue working through this section in the next video, relating these things to some inverse trig functions as well.